Lesson 4.4. Find rational zeros of polynomial functions. All right, we have a theorem. Today we get the remainder theorem, which says if a polynomial is divided by x minus k, then the remainder is the value f of k. So in other words, if you want to find the value of f of 2, let's say, we could do synthetic division with x minus 2. The remainder would be our value. Think, well, that sounds like it's really long. Actually, with synthetic division, it's really short. To use the remainder theorem to evaluate a polynomial, you're going to use synthetic division to divide by x minus k, and the remainder is f of k. It's quick, easy to do, usually by hand. So let's use the remainder theorem to evaluate this function at x equals 2. All right, so we divide by x minus 2, so I'm going to put 2 in our box. And then the coefficients are 3x to the fourth, negative 5x cubed, 0x squared, 1x, and negative 14. Bring down the 3 and multiply. 2 times 3, 6, and then we add. We multiply 2 times 1. We add, multiply 2 times 2. We add, multiply 2 times 5. Then we add. The remainder is negative 4. Therefore, f of 2 is negative 4. And you could double check that by plugging in a 2 in your calculator. 3 times 2 to the fourth minus 5 times 2 cubed plus 2 minus 14. Let's see. 2 to the fourth is 16. 2 cubed is 8. 3 times 16 is 48. 5 times 8 is 40. 48 minus 40 is 8, plus 2 is 10, minus 14 is negative 4. Look at that. You get the same answer, only it's much easier doing the synthetic division. We also get the factor theorem, which is kind of just the definition of a factor. It says k is a 0 of f of x if and only if x minus k is a factor of f of x. So we're saying if the remainder is 0, then it's a factor. And k is a 0. What's a 0? A 0 is the value of x that makes your function equal 0. So k is a 0, or makes it equal 0 if the remainder is 0. All right, so use that to solve a polynomial equation. So if you're given one factor, use synthetic division to divide by that factor. You confirm the remainder is 0. If the quotient is not a quadratic, you repeat steps 1 and 2 with another factor using the quotient as the polynomial. Remember, I called these the depressed polynomial. So you're going to use the depressed polynomial for the second time around, and the third time around it'll be smaller and smaller and smaller as you get rid of factors. Eventually your quotient will be quadratic, or the depressed polynomial will be quadratic, which you can factor. And then to get the zeros, you set each factor equal to 0 and solve for x. All right, we're going to show that x minus 2 is a factor of this function, and then find the remaining factors. So first thing, let's do synthetic division. So we'll put the 2 in our box, and then have our coefficients. It's 1x cubed, 7x squared, 2x, and minus 40. Bring down the 1 and multiply. Add, multiply, 2 times 9. Add is 20. Multiply, 2 times 20 is 40. Add, look at that, we got a 0. Hey, it was a factor. Now we have our depressed polynomial. It was x cubed. We divided by x, so now it's x squared plus 9x plus 20. Which we could maybe factor. It is quadratic. If it was not quadratic, we'd use that depressed polynomial, that result, with our next factor to keep making it down until it is quadratic. Let's see, to get 20 might be 4 times 5, which in fact adds up to make 9. So, completely factored, it's x minus 2, which they gave us up here, and then the x plus 4 and x plus 5. There, we have factored it. Show that x plus 2 and x minus 1 are factors of this polynomial. So again, we're going to take one of the factors. It's x plus 2, so that's x minus negative 2, so we'll put negative 2 in the box. And then the coefficients of the polynomial. I have 1x to the 4th, negative 4x cubed, negative 3x squared, 14x, and negative 8. That's all the powers of x, so I don't need any zeros. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and oh, we got a 0. It was x to the 4th, so now we're at x cubed, minus 6x squared plus 9x minus 4. That's not a quadratic. So we're going to use our second factor. So we'll put 1 in the box. And instead of going to the original polynomial, we're going to use this depressed polynomial that we just got. So just copy down those numbers from the answer we just got. Bring down the 1, multiply 1 times 1, add, multiply 1 times negative 5, add, 1 times 4, add, oh look, that's also a 0. So that was x cubed, so now we're at 1x squared minus 5x plus 4. That is a quadratic, so I might be able to factor that. To get x squared, it'd be x times x. To get 4, might be negative 4 and negative 1, so it adds to make the negative 5. So my factors are the x plus 2 that I started with, the x minus 1 that I started with, then the x minus 4, and then I have another x minus 1. So instead of writing times x minus 1 again, I'll just square the x minus 1 that's there. And there it is, completely factored.